Hey everyone, welcome back to another video by Camroom 5. In today's video, we're going to be solving some past paper questions of periodicity. So let's begin this question. It says, which graph correctly shows the relative melting points of the elements magnesium, aluminium, silicon, and phosphorus plotted against their relative electronegativities? Now notice, they are talking about the melting points of these elements against electronegativity. So we're going to highlight that so that we know what we are talking about and why we are talking about it. Melting points and then electronegativities. We know that across the period from magnesium, aluminium, then we have silicon and phosphorus, the atomic numbers increase. We know this because we are moving from left to right, so atomic number is increasing, and also their properties are also changing. So with more nuclear pull, more nuclear charge, the electronegativity increases. So technically phosphorus should be the most electronegative atom among these compared to magnesium, aluminium. Magnesium and aluminium are metals, so they don't have electronegativity at all. That is why option D for doctor is totally stupid option, because they are putting phosphorus with very small electronegativity. Even C is wrong. A or B could be good answers. Now going for a better explanation, I know that in terms of melting point, silicon has the highest melting point, and that is because silicon has a giant covalent structure. So compared to phosphorus, silicon has the highest melting point, which is on the y-axis. So focus on the y-axis. Phosphorus should have low melting point, silicon should have a very high melting point. Because phosphorus is P4, a simple molecule, silicon is giant. So you can say that silicon has a higher melting point. Option A is again wrong, because they are putting the melting point of silicon lower than the melting point of aluminium. Even though electronegativity of silicon is higher, but again melting point makes option A for apple wrong. So B for barrows. Now let's do question 13, question 12 first, which belongs to this paper of 2021 March. Which observations are made when a sample of silicon chloride is added to a beaker of water? Now we know that when silicon chloride goes into water, it hydrolyzes, which means it will produce silicon dioxide and 4 moles of hydrogen chloride. Silicon dioxide is a white precipitate and hydrogen chloride has white fumes. They do dissolve and they produce, acidic solution. So white precipitate and also fumes of hydrogen chloride. Um, let's see. Let's write it. By the way, I am writing these fumes plus acidic solution. I'm writing this because even before reading the option, I would know what I'm looking for. Option A is wrong because it says no observation. Option B talks about steamy fumes of HCl and precipitates are both observed. So option B is a good option. Option C says the appearance of a precipitate is the only observation. Wrong, because what about hydrogen chloride? And D is also wrong because it talks about only steamy fumes. Let's go for question 13. It says which row is correct. There's a statement and there's a reason for it. The first ionization energy of phosphorus is greater than that of magnesium. If you compare magnesium and phosphorus from their positions in the periodic table, let's write, why am I writing silicon? Sorry, like magnesium, aluminium, silicon, phosphorus. Magnesium has an atomic number of 12, then 13, 14, and phosphorus is 15. We know that phosphorus has more nuclear pull, more nuclear charge, so higher ionization energy. I totally agree with that. But my concern is the statement for the reason. The reason rather. It says electron is lost from a 3p orbital. That is not the case for magnesium, not the case. Why? Because magnesium doesn't have an electron in 3p orbital, so A is wrong. Option B, the melting point of phosphorus is greater than that of magnesium. Totally wrong, because phosphorus is a simple molecule. If you remember, phosphorus has a very low melting point compared to magnesium, because melting point of magnesium is higher because of the metallic lattice it has. phosphorus is simple molecule. So greater की वजह से that is wrong. Option C. The atomic radius of phosphorus is smaller than that of magnesium. Now that is true. Why? Because magnesium has 12 protons and phosphorus has 15. They both have same number of shells. So they both have 3 shells each. Both have 3 shells, 3 quantum numbers. But with more protons, phosphorus pulls the electrons towards itself. Phosphorus का जो nucleus has more protons, so it's gonna pull the electrons towards itself. So the overall atom becomes smaller because all the electrons are pulled towards the center. That is not what happens in magnesium. So magnesium is bigger, phosphorus is smaller. And that is correct. Phosphorus has greater nuclear charge. Let's see option D still for our satisfaction. The electrical conductivity of phosphorus is smaller than that of magnesium, obviously because phosphorus is a non-metal with covalent bonding. Bonding changes from ionic in magnesium to covalent. That is wrong. Ionic bonding is not in magnesium. Magnesium has metallic bonding. It's a good confusing point here because people might think that magnesium is ionic bonding. Pure magnesium is a metal, guys. It has a metallic lattice. Let's do this question. It says, which dot and cross diagram is correct for aluminium chloride? You know, aluminium chloride makes a dimer, which is a dimer of AlCl3. So it's a dimer of AlCl3. Now we know that it is made when there is aluminium chloride number 1 and there's a dative bond formed. It is covalent, not ionic, guys. Option A is wrong. It is not ionic at all. When we talk about option B, we can see there's a covalent bonding here because there are electrons being shared. So let's identify the bond pairs and lone pairs. There's a bond pair between like aluminium and chlorine, 3 bond pairs, and then there's another set of bond pairs with another chlorine and aluminium. But notice one thing, there is 2 dots from chlorine to aluminium, which means a dative bond because chlorine donates a lone pair. Similarly, the chlorine at the bottom donates a lone pair. That is called dative bonding. In dative bonding, you can see the 2 dots of the chlorine, which are the electrons of chlorine, are shared. Option D is categorically wrong. Why? Because 2 aluminiums are making bond with each other. Not possible. Aluminium don't bond together, guys. That is not possible. They are metals. So not possible. Option D is stupid. Going for option C, we can see that there's again covalent bonding here, so which is good for us. So aluminium are making dative covalent bonds here, but my concern is that all of these are dots and crosses. As far as I remember, there should be 2 dative bonds, but there is no dative bond. No dative bond. That is wrong. Option C, that is why is wrong, because there should be 2 dots from chlorine going to the aluminium. Remember, chlorine is the lone pair donor and aluminium is the lone pair acceptor. So there should be 2 dots from chlorine going to aluminium. Let's see this question. It says, sodium and sulfur react together to form sodium sulfide. How do the atomic radius and the ionic radius of sodium compare with those of sulfur? Now let's compare the atomic radii first. You know, when we compare sodium, and we know sulfur is on the right hand side of the period. Sodium has 11 protons. Sulfur has 16 protons. Sodium has a very bigger radius because it has fewer protons, less nuclear charge, but sulfur has a smaller like atom, smaller radius because sulfur has more protons. So the radius of sulfur is very smaller than sodium. And we are talking about atoms, so no charge. But when we talk about their ions, sodium ion is formed by losing an electron. And by losing an electron, sodium has 2 shells. Sulfide ion is made by gaining electrons. So sodium is different because it had 3 shells, now it has only 2 shells. It lost the electron, that is oxidation. So sodium ion has a smaller radius. When we talk about sulfide ion, it has a negative charge on it. It has a bigger radius. Why? Because there's electron repulsion here. So because of the electron repulsion, sulfide is bigger. So sulfide is much bigger than the sodium ion. Let's look for our options. I am very comfortable with option C and D because it says atomic radius of sodium is bigger. I agree. But when we go for ionic radius, option D makes sense because ionically sodium ions are smaller and sulfide ions are bigger. So D for doctor is a good answer. Moving on to the next MCQ. It says solid aluminium chloride sublimes at 178 degree. Which structure best represents a species in the vapor at this temperature? Aluminium chloride is not ionic. So D is a stupid answer because you can't have aluminium and chloride ions. It's not ionic compound. It's not even C because aluminium chloride makes a dimer, where aluminium gets the lone pair from chlorine. Chlorine is the lone pair donor. If you look at option B, they are giving the arrow from aluminium, which is wrong. Aluminium is not a donor, it's an acceptor of electron pair. So B is wrong. Let's go for option A. Option A makes more sense because chlorine is donating the electron pair and the arrow is going towards aluminium, so it's accepting. So A is a good answer here. Which oxide does not react with cold dilute sodium hydroxide to produce a salt? Sodium hydroxide is an alkali, so it's reacting with acids and amphoteric substances. Sodium hydroxide plus acidic oxides is okay, and even amphoteric oxides is also okay. So I can have acidic oxides which are purely soluble acidic oxides. SO2 is an acidic oxide, so it can make a salt. And phosphorus 5 oxide also. So they will react. The question is asking not react. So sulfur dioxide will react, phosphorus 5 oxide will react. When you notice aluminium oxide, it's also amphoteric, which means it will also react to make sodium aluminate. If you remember, it makes sodium aluminate. The only thing which won't react is silicon dioxide because silica reacts with only concentrated. SiO2 reacts only with hot concentrated sodium hydroxide. So moving on, I really like this particular question. It says the graph shows trends in 4 physical properties of elements in period 3, excluding argon, which graph has electronegativity on the y-axis. If you remember electronegativity, it depends on nuclear charge. So sodium, magnesium, aluminium, and then like phosphorus, sulfur, chlorine. Sodium has an atomic number of 11, chlorine has 17. So chlorine has more protons than sodium. The nuclear charge and nuclear pull increases from sodium to chlorine, which means electronegativity should also increase because more nuclear charge pulls the electron pair towards itself. So option B is a stupid option because it's decreasing whatever the value it is. So sodium doesn't have highest electronegativity, it has the lowest. Electronegativity should increase gradually. When you look at option C, it's increasing, that's good. But why aluminium's value is decreasing? And also notice, why is the value for sulfur also decreasing? So C is also a stupid option. By the way, if you remember, aluminium and sulfur show a drop in ionization energies. So option C is actually a graph of ionization energy where you can see that it's decreasing. Option A has the highest value for silicon. Silicon has the highest melting point. So the graph option A is melting point. Only option D is increasing gradually without a bump. So option D is the right answer here because that is the electronegativity value gradually increasing from sodium. So option D is a good answer. By the way, option B is the atomic size. You can notice sodium has the biggest atomic radius and chlorine has the smallest atomic radius. When the electron pairs are pulled, the atom becomes smaller. Option D has highest electronegativity with chlorine and lowest with sodium, which is the case, which is true. So option D. Let's go for this theory question. It says, on the axis, sketch the trend in melting point of the elements sodium to sulfur. Moving on, it shows you an axis with atomic numbers or elements at the bottom and then melting point. We need to understand the structure and bonding of these elements. Sodium, magnesium, and aluminium are metallic. So sodium, magnesium, and aluminium are metallic elements with their metallic lattice and stuff, with their like attractive forces. Silicon is a giant covalent, and then phosphorus and sulfur are simple covalent molecules. Silicon giant covalent, and then phosphorus and sulfur are simple covalent molecules. Phosphorus is P4, sulfur is S8. So sodium has low melting point around 97, then magnesium and aluminium have higher. Silicon has tremendously higher because of the giant covalent structure and stuff. Phosphorus and sulfur have low. But remember, phosphorus has a little lower than sulfur. Why? Because phosphorus is P4 and sulfur is S8 molecule. Obviously sulfur has a bigger molecule, so sulfur has more ID forces. Instantaneous dipole induced dipole forces are more in sulfur, less in phosphorus. So even this is how they draw an exam also. I'll show you. So I'll draw the graph here like this. There should be a little increase from phosphorus to sulfur. If you remember the question that we did earlier, it also had a graph like this. Notice on question, like on of the option A, phosphorus has a little lower than sulfur. That's because P4 molecule has lesser ID forces than S8 molecule. More electrons, more ID forces. Give three statements to explain your sketch here. So I would say that sodium, magnesium, and aluminium are metallic. So I'll write sodium, magnesium, and aluminium are metals with metallic lattice and high electrostatic attractions. I should write strong electrostatic. Let me write. I'll change it. Strong electrostatic attraction. At the end of the day, they mean the same thing. When you talk about silicon, silicon has a giant covalent structure with large number of strong covalent bonds. Large number of strong covalent bonds. And that is the reason it's not easy to break them. I'll just mention about why phosphorus and sulfur behave this way. Phosphorus has smaller melting point than sulfur, as for P4 has lesser ID, or you can say London dispersion forces than S8, and you can explain it even further by saying because P4 has fewer electrons, and that is why the ID forces are smaller. Moving on, write an equation for the reaction of P4O10 with water. So we can see that P4O10, which is phosphorus 5 oxide, reacts with water to produce phosphoric 5 acid. It has the formula H3PO4. It's called phosphoric 5 acid because oxidation number of phosphorus here is 5. Let's balance it. We can see there are 4 phosphorus atoms on the left, so I'm putting 4 on the right. Then you can see the hydrogens become 12 because 4 times 3. So I'll put 6 before the water to just balance the water molecules here. And then you can see oxygens are like 10 on the P4 molecule and then like 6 more. So 4 times 4 should be 16. Oxygens are balanced regardless. So I'm done with that. Sulfur dioxide can be released into the atmosphere when fossil fuels containing sulfur are burnt. Say and explain one environmental consequence of the release. So acidic oxide, and then you can talk about it dissolving in the atmosphere, dissolves in like the moisture or the clouds and stuff. And then you can talk about um, it causing acid rain, and then you can still talk about how acid rain is problematic. So it was a general question, not exactly period 3, but we did it. So I hope this idea is clear to us. In the next video we'll do more of those. Stay tuned, guys.